let's look at, alright. Here, we got A, right, equals 44. Alright, we got B equals 26. And here, all right, and let's put our third vector here. We're gonna call it C, and we're gonna say it's 11 units long, and we're gonna say here theta is right around 48 degrees. Here theta is 25 degrees, and here theta is 35 degrees. All right, and so I want you to 1, 2, 3. Right, let's do A plus B plus C, the basic one, right? And then let's do 3B minus 2A plus 2C, okay? And let's do 3B plus 4C minus 2A, okay? So we want to add these, we want to add answer, basically get the resultant vector, right? We want to calculate resultant vector. That's what we're doing, right? Resultant vector is what? A plus B plus C. 3B minus 2A plus 2C. 3B plus 4C minus 2A. Those are resultant vectors because they are the result of the addition of these, addition and subtraction, however you want to look at it, right? So, what's the first step when we're dealing with these? Huh? That's in the component method, right? In the component method we do, in the tail to tip method, right? We're doing component method right here, right? So what's the first step? Get the components for each vector. How do we do that? So we can write it over here, right? Let's start with A, vector A, and we say what? X component, Y component, right?
Yes.
How do we get them?
Cosine, well, X is to be well, what is that? What's the
So here, right? That would be what?
Yeah, but what's the magnitude of A?
44.
Oh, it's 44. Oh, it'll be 44 cosine 48.
Okay. So everybody following how she got that? Okay, 44 cosine of A, right? Cosine of 48, sorry. Right? And then what?
And Y is 44 sine 48.
And 44 sine, right? Sine 48, sorry. Okay? And we can get numbers for those. And then we can go to the next one, right? Okay? B. How do we get X and Y components for B?
B is
v of x, this is v of y, right? So for the x, we're gonna do what? Cosine, right? So it's gonna be what? 26 cosine of 25 degrees. And then we're gonna have for the y, 26 sine of 25 degrees. And of course, we recognize that since we're in the second quadrant, that our x component is what? Negative. Now what about C?
See the x component is 11 sine 35.
All right, so we got, that's our what? X component, right? And that's our y. So we have what?
See, 11 sine 35.
11 sine 35. And what? 11 cosine 35, right? And because we're in the 1, 2, 3, 4th quadrant, we know x and y are.
So why is the x sine?
I mean, well, huh?
Why is the x sine instead of cosine for C?
Y is the x sine because x is what? Sine is what? Opposite. So we take the opposite of this angle. It's the x component. Following? So the adjacent of this angle would be this one, right? You just move it over here. See that? So that's why I say it depends on the angle, right? Most people just try to memorize which, say, oh, x is sine and y is cosine. Only in the in the first quadrant. That's what most people deal with, is just the first quadrant. But in physics, we deal with all 4 quadrants, right? So 360 degrees, okay?
Would C,
Yeah, see,
y for C be negative?
yes, right? And x will be what? Positive. So they're both not negative, sorry. All right, so the y is negative, right? And this x should be positive, because we're in the 4th quadrant. Negative 11 cosine 35. All right? Now, what are the numbers? Do we have numbers for all of those? Let me make sure our calculators are in degrees and we know how to put them in degrees. And I'm gonna leave 2 and 3 for you guys to practice on your own, right? And of course, when you see the coefficient outside of the vector like that, then that just means what? We multiply the number times each component. That's
So
it.
you multiply the 3 by the x and y component of,
B,
and then you do the
multiply
same.
the 2 times the x and y component of A. Because the x and y component make up A.
Okay,
And
and
that-
then, sorry,
Go ahead.
Go ahead.
no, you get it, I think it's the same question.
Oh, in that, like, what does that get, is that just gonna be a question on the test? Like, what does that give us? What is,
This is the mathematics of vectors. So when we do projectile, that's the whole reason why we did this, is to understand projectile motion.
gotcha.
This is how you understand projectile motion, right?
I know
Because
that, I'm talking about 2 and 3. Like, what do the, I don't think I'm asking it correctly.
what
What's
do
the purpose, like,
Yeah.
what's an example of doing it?
a real world example?
Is that-
This is just math. That's what I'm saying.
Oh,
This is
okay.
just vector math, showing you how. I'm sure there are some real world examples. I can't think of none off the top of my head, right? Maybe if somebody said, "Oh well, if object has an initial speed of v," and then they ask you a question and say, "Oh well, calculate the horizontal distance if the initial speed was 3 times v. Then you'd have to multiply 3 times v sub x and v sub y. You got me?
Yeah.
That's one. There we go. But here, this is just math.
Okay.
We just doing math to get you to understand vector mathematics. And that's what we really applied to. So see how we started off with free fall motion. That's motion in one direction. Then we looked at vectors, because vectors allows you to do what? Split it up. See? So we understood vectors, and now we're talking about, well, now we're on the Newton's laws, but we were talking about projectile motion, right? All right, so let's just finish this one out, right? 44 cosine 48, what is that?
29.4.
29.4. You see, that's why we don't have any units here. Right? In physics, they would say you should do what? Write units there. Because this is math. It's not a real thing, you know? It's not like 25 tomatoes, 25 apples. It's just math. Right? So, what's this number? 32.7 units. All right, and negative 23.5 units. 26. All right, 11 units. 6.3 units. Negative what? 9 units. All right. Now we're gonna add A plus B. So let's erase these. So y'all got the 2 and 3 written down already, all right?
Yes.
I'm gonna erase it because I need the space. And you guys can practice that on your own, right? A plus B plus C, right? So A plus B plus C is equal to what? AX plus BX plus CX, right? All of that is the X component of the resultant. Plus what? AY plus BY plus CY. And that's our Y component of our resultant.
So you would have an X and Y component in your resulting answer.
Yes, because your resultant is a vector with 2 components.
So it wouldn't be just one big answer, it would be a.
No, it's an X and a Y component. Yep. You're gonna see at the end when we solve it, right? And so, so then we just plug in the numbers now, right? 29.4, right? Plus negative 23.6. Yeah, BX, right? 23.6 plus 6.3, right? Right? That's my X component plus AY 32.7 plus 11 plus negative 9. That's my Y component. All right? So what's the final result, somebody?
I got 12.1 for the X.
So 12.1, and then we're gonna write X there, plus what?
34.7 for the Y.
34.7 for the Y. So this is my resultant vector right here. X and a Y component. So this is what A plus B plus C equals this. Now, how do I find the magnitude of that vector? Of what? What do I use in my Pythagorean theorem?
Oh, you use the X and the Y.
The x and the y components.
Yeah.
Alright, so the magnitude of a plus b plus c is gonna be what? A plus b plus c, and I put the absolute value symbol there just to let you know that it's magnitude, it's just a number, right? It's gonna be what? Square root of 12.1 squared plus what? 34.7 squared. That's my magnitude. What is that? Anybody?
I have 36.7.
36.7? 36.7.
Me too.
Okay? Now, how do I find my direction?
Inverse tangent.
Inverse tangent. I'm gonna erase this right here, okay? This right here. Inverse tangent of what?
Y over X.
Y of x. Y is 34.7 over x is 12.1. What's my direction?
.9.
63.9 degrees. All right, so we got a magnitude and a direction for our resultant vector. Now, let's do tail to tail. So we did tail to tip. We redraw our Cartesian coordinate system. Our first vector A is like right here, right? Right?
Yes.
Okay, so we're gonna take our second vector and put it at the tip of our first vector, all right? So it's gonna go somewhere like this, and it's kind of short. So I'm gonna do it like that, right? And we're gonna take our third vector, which is C, and put it at the tip of our second vector, right? And so we're gonna say C, and this is gonna look weird to you, but it is what it is, right? So we put C, so we take C from right here, because this is right here now, right? We're gonna take C and put it right there, right? So basically it's erasing part of a little bit of what? Of B. Now following what I'm doing? Maybe I should have a different color chalk. I don't have enough for 3, right? But this is 3 vectors, right? So, well, maybe I'll make this one dash. So this is B. Let's make B a dashed white. That's B, right? Right? And so C would be, right, sort of the same way, right? It'd be kind of coming back. Right? And it might not be as long. That's probably a little too long. All right, so let's say about right here. About right here. All right? And remember, this is not drawing the scale, right? Okay? And so now if I connect my what?
Result, I mean the
The
origin.
tail of the first vector to the tip of the last vector. Then I get my resultant. Right? That's my resultant vector. And so that means that what? This angle right here is what?
36.
No, 63.9, the one we just calculated using the component method.
I thought that was.
You thought what? Direction is a angle. See, we don't practice enough. Alright? Direction is an angle. That's what direction is, an angle, 63.9 degrees. Right? It is an angle. Just like here. This tells me my direction of my vector. Any questions about that? So this was tail to tip. Right? So what's the magnitude of this vector? 36.7. I just wanted to see if we was gonna get that right. Alright. Alright. And this is what? Component method. Component method. Right? Alright. So don't let it shake you up if you see the numbers there. Right? When you see the numbers and you see 3b plus 4a minus 2c, that means what? That the x component of this resultant has a what? X component for each one. So it's gonna be what? 3bx plus 4ax. You see that? Minus 2cx, yes. And then the y. Or cx, sorry. That's just, I just made that up. Like I was telling you, it's math, y'all. It's math. I'm trying to teach you how to do vector math. That's where the numbers came up. We made them up like you make them up in math. You don't make them up in physics though, but you make them up in math. Okay? So we're doing math today. All right? But eventually this leads to what? Projectile motion. Okay? Where all of the numbers are not just coming out of thin air. But here we're just making them up. All right? So it'd be 2cx. And then I have what? And that'll represent my what? X component. And then I have what? Plus 3by plus 4ay minus 2cy. And that's my y component. Right? But if I just go ahead and, you know, I mean, it depends on how you want to do it, right? Because if you just go ahead and say, oh, well, I'm going to find out what 3b is, right? I'm just going to do it. Remember how we were doing it at first? I just say, all right, well, here's b, or 3b. 3b has a x and y component.
I'll just multiply that.
Yeah, just go ahead and multiply it right here. You can do it like that, or you can do it like that.
I think this one is.
Okay.
This is the right one.
Right? All this means is that when I get my x component, I'm gonna multiply it times 3. And my y component, multiply it times 3.
And then add them.
And then add them instead of doing it right here. You follow me?
Yes.
Good. All right, so that's it. That's it on that vector stuff. All right? Well, at least vector math, okay? I'm gonna do some projectile motion. And That's the reason, that's the whole reason why we learned how to do this, for projectile motion. Alright. So let's just write down some things, right? So we're gonna say, we're gonna say, well, we're gonna, well, we're not even gonna deal with free fall, okay? Cause we're not dealing with, well, what do you think? No, we're not gonna deal with free fall, so that's not even right. Constant acceleration equation, right? Acceleration equation. Okay? And what is it? The y or the x could be in the y or the x, depending on what we're talking about, right? Because we're talking projectile motion. But normally we're talking about the y, right? Plus 1/2 gt squared, right? That's where we starting from. That's where we always start from, right? And a lot of times in the problem it's gonna say, oh, well, the object is at some initial speed, v naught, and some what? Theta. Gonna say, oh, well, it's at 15.2 meters per second, and it's 33 degrees from the horizontal, okay? So when I see that, immediately I know what? No. What do I know when I immediately see the angle? What have we been doing with angles? No.
Wait, what was the question?
I said, what do I know when I see an angle? What do I know immediately when I see?
Moving in the Y?
No.
There's
What have we, the only thing we have been doing with angles?
Is it direction?
Yeah, components.
Oh.
Yeah. Goodness, y'all. All right, so I like to draw it out, right? So I can visualize it. Here's my V. Same thing we've been doing, right, with the vector math. Okay, V is what? 15.2 meters per second. And here's my angle of 33 degrees. So then I can draw my X and Y components. And I can see them clearly. Vx and Vy. Right? And so now I can get my V of X and V of Y. Right? V of X is what? 15.2 cosine of 33. 15.2 sine of 33. Excuse me. So then the problem is gonna say, oh, well, do it with this initial speed, and it ended up on the ground. He threw it from his shoulder, right? So your y naught, or y equals 0, is at his shoulder. So we're gonna say his shoulder was 1.7 meters from the ground. So that's my height. That's the y, right? Right? So you see how we taking this from the word problem to what it means mathematically. That's my height. I threw it from the ground, but it hit on it. I mean, I threw it from my shoulder, but it hit on the ground. So my height is from what? My shoulder to the ground. Right? That's y. Right? And we said it's what? 1.7 meters. And because I chose 0 at my shoulder, then I know that what? 1.7 is negative. So this y is negative 1.7 meters. And I know my y naught is what?
0.
0. We chose the shoulder to be 0. So now I come here and I add what? VO and the y. What is VO and the y?
8.3.
8.3? Okay, so I got 8.3 here. Well, everybody got 8.3? 8.3 meters per second times t. Right? Plus what? 1/2 g, right? 9.8 meters per second squared. Right? And then we have what? T squared. So now what do I do from here?
Is it 15.2 cosine 33 or 35?
Oh, so it's 33. I just wrote it bad.
No, I didn't do it.
33.
Oh, I didn't get 8.3.
Did I miss it?
No, I didn't.
So doesn't that mean you put the 1.7 on the other side?
Yes, I need to write from what? Left to right, so it can look like my quadratic equation. Right? So I didn't change any direction yet. Let's just write it from left to right. So it's gonna be what? 1/2 9.8 t squared plus 8.3 t plus 0 equals minus 1.7, right? I just swapped the order. I mean, not the order, I just flipped it.
Yeah. Yeah, from left.
So it looks, from left to right, so we can understand it better. So it can look more like what? Ax squared plus bx plus c equals, it's not, we'll get there. We'll get there on the next step, right? Because all we gotta do is do what? Bring it over to the other side, right? And so now we have what? 4.9. I'm gonna go ahead and take half of the 9.8. T squared plus 8.3 t, right? Plus 1.7. Okay? And I think I missed this right here, right? That's gotta be negative, right? That's gonna make that negative. I think so. But sometimes I get confused, right?
So if it's going down, that means that the gravity's gonna be negative?
Well, is it because you throw it up?
Right.
And then that's why
Yes,
it's negative?
yes.
Okay, so.
Yes.
Okay.
So sometimes, right, and so this is how I like to do it, and I'll just tell y'all this, right? So I like to wait until I get to the end, my quadratic, when I'm solving my quadratic equation. If I get, if I get the negative value underneath if I got a negative discriminant, which is b squared minus 4ac, then I just change the, yep. That's how I've been doing it since I've been in physics, okay? So, sometimes the reason why, I don't wanna tell you one strict way is because they have so many situations that can change and blah, 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 all right? So, but anyway, let's see though, all right? So now we got A is equaling what? Negative 4.9. Let's write it over here. A equals negative 4.9. B is equal to what? 8.3. Is it 3? Yeah, 3. And then C is equal to what? 1.7. Now put that into your quadratic equation, right? And we should get one positive number, one negative number. If we don't, then that means that, yeah, we gotta go back to positive. I think it's right though.
And how do I make sure my calculator is in degree?
Mode. Go to mode.
Oh, it is. Well, then why am I not getting the same thing that I'm getting?
With what?
Which, sine and cosine?
Let me see it.
Don't have dirty it. What was the last one that we did?
You didn't get 8.3 for 15.2 sine of 33?
Mm-hmm. Oh, sign?
Yeah.
Oh, I did. Go sign that way. Never mind.
Anybody got some times yet? So this gonna be the time of what? If I said the guy threw it from his shoulder, right? So let's hear our cartoon is right here, right? So the guy threw it from his shoulder. It's gonna come down and boom, hit the ground, right? Here's the ground, right? So here's my one time is gonna be from what? From here, let's say from here, all the way to what? Here. That's my one time. That negative time is gonna be where? From here, as if I was doing what? Hitting reverse on, that's why it's an imaginary time. That's why we throw it away, because it doesn't make sense. Not in the real world, only in mathematics, right? So that second time that I get, that's this time right here. So you see that completes the what? Trajectory of the projectile motion. So if the guy wasn't there, then the object would go back like that. So imagine if I had somebody, if I was recording somebody throwing a shot put. If I take that, after they threw the shot put and it hit the ground, if I took that recording and I hit it and I put it in reverse, the shot put's gonna come up back to their shoulder and it's gonna be at 0 when it hit their shoulder. And then if somehow we can make the video keep going back, it's gonna go negative in time. You following me?
That's why it's two.
That's why there's 2 times. It's gonna go negative in time and it's gonna go all the way back to the ground.
Okay.
That's why you calculate a negative time. And that's why we call it imaginary. Remember imaginary numbers from math?
Yeah.
Yeah. So anybody, come on. Waiting for my time.
I got 1.88 and negative 0.18.
Great. So we got what?
1.88.
So I got my time. Of course, we're gonna have 2 solutions, right? Because we got a quadratic, second order quadratic. So we got 1 point what?
88.
8 and what?
Negative 0.18.
0 point what?
18.
18 seconds, right?
Yeah.
So that makes sense, right? That from here to here is about 1.8 seconds, right? And then this little piece is negative 0.18, right? So the question is, calculate the horizontal distance. So now that I got the time, I multiply that times what? To get the distance, what do I need if I got time, huh? Speed. Where am I gonna get speed from? Where am I gonna get speed from? Look at the board. Where am I gonna get the horizontal speed from?
Oh, 15.2.
Vy is not horizontal. Vy is vertical. The x. Vox. Okay? So again, we use Voy to get the time. Once we get the time, then we multiply times the speed to get the horizontal distance. Okay? And remember, so what's the 2 situations? I kick from the ground and I end up back on the ground. In that case, I solve my quadratic by doing what? Factoring. This case, I threw from my shoulder and it ended up on the ground, right? Or I can do what? Kick it from the ground and it end up on what? On top of a building. in each case, the ball doesn't end up in the same place it was launched. Yes. Okay? So these are the situations.
And
Any-
so if you started from somewhere and it ended in the same place it started, the y would be zero.
0. Yes. That's the crux of it right there. You know that's the physics. This goes to 0. So then what happens to my quadratic? Then every term has what in it? Once this goes to 0, then every term over here has what in it? 0. Every term, what is a term? Do you know what a term is?
I don't know
We're
where
in an equation. On a quadratic equation, there are terms. Where are the terms?
What is the question?
Like,
What's the overall question?
She said, if I kick the ball from 0 and it ends up back on 0, this goes to 0, right? This is 0. Okay, so my question to you is, if this goes to 0, then in this equation, what is in every term? No. This is 0, this is 0.
Yeah.
Then we have these two over here. So I'm asking, what is in every term left on this side of the equation?
Time?
T. So if it's in every term, then I can do what with it?
Factor?
Factor. That's what I'm getting to.
Oh, okay. I think I was just confused with the question.
Yeah, I know what it is language, y'all. I'm telling you, it's language. We might know how to do all these things, but we don't use the appropriate language. I'm telling you what it is. Right? It took me some time to get there too. I'm telling you. It took me some time to get there too. I used to think it was ridiculous, you know what I'm talking about, you know what I'm saying. Blah, blah, blah. But it's really language, I'm telling you. And that's in everything you do. Even in your biology classes or whatever your major is, animal science, whatever it is, right? Everything starts with language, right? We can't do mathematics without a language, without talking to each other. So everything really starts with, we like to think math is so important, but really, language. Because if we didn't have a language, then we couldn't do math, because we couldn't communicate. So it's language. All right? So any more questions about this?
I got 23.9.
You got what?
23.9.
23.9 meters? That sounds about right. Horizontal distance would be about 23.9 meters. Yeah. All right, so we go back to the lab. Our ball was traveling, it's a little bit slower, right? Our ball was at like 3 meters per second or something like that? I remember correctly, I can't remember exactly. But it was at like 3 meters per second, and I forgot what horizontal distance we were calculating. Right? But it's an easy way, once you get your answer here, then you think back to your lab, and you say, does this make sense? Because this is exactly what the lab was. It's just the person is the rocket launcher. This is exactly what the lab was. So you think back and you say, oh, in lab class, when my speed was, here is 15.2, right? Imagine this is the test on the exam. Then you say, all right, well, it's 15.2 here. In my lab class, it was about 3 something, right? So I'm gonna do what I'm gonna do. I'm gonna take this and I'm gonna divide it by 5. And then I'm gonna say, oh, well, come here and get this, divide it by 5, and see if it matches up.
It's consistent.
Yes.
Okay. All right, buddy.
This is what I'm telling y'all about Does my answer make sense? That's why there's a lab component to your science courses. Because you're gonna get to do what you do on paper all the time, you do it in real life, so you can connect the two. And then you can say, oh, well, the next time you gotta calculate the thing on paper, you can say whether or not it makes sense or not. Because you actually done it in real life. Right? That's the essence of STEM. Right? Everything we calculate on paper, we do in real life. Everything. Yeah. And they should match up. It's not a fairy tale, right? All right, so there are no more questions. Golly, I'm like I'm in Georgia or something. 12:42.
You said the test is Wednesday?
Yeah, let's do it Wednesday.
We got a field trip for soil and water at the River Center on Wednesday.
Okay.
She gave us an excuse to do it,
All right.
but like, let me look.
You take it like later next day
No, y'all gonna have to miss the field trip and take the exam on Wednesday or else.
Or
or
else.
else? I choose
Nah, it's all good, whatever. Just take it on Friday.
Okay.
Oh, and there's also a
A quiz
quiz on Moodle.
on Moodle?
Yeah.
That's a mistake, because I mean, it's just something I probably did in previous semesters and just forgot to, close it. Yeah.
So, did you get those papers that?
Oh, yeah, I got them. Oh, you did? But, so, that was, so, what we,
No, I'm talking about the, one that we had to turn the paper in.
yeah, you,
Yeah, I didn't turn it in online, but I
Don't.
turned the paper in to him.
oh, don't worry about it. Oh, no, I just put that up there because I didn't think, I'll just put that just in case he didn't show up. So y'all would still have it, you know what I'm saying? That's the only reason why I put that up there, so, yeah, you good.
I got something to read it.
All right, see y'all later. Uh-oh, what is going on? There we go.